Alright, let me get to the spec here. In this video, we're asked to write a method called removeMatchingLeaves that'll be added to an entry class. It'll accept the second entry as its parameter, and it'll remove any leaf nodes in the first tree that match a corresponding node in the other tree. So, for example, if we have these two individual trees here, we see that tree 1's nodes are 0, 8, or leaf nodes are 0, 8, 6, 2, and 5. And we look at tree 2. Tree 2 has a corresponding 0, an 8, a 6, a 2, but it does not have a 5. But the thing is, we only remove the leaf nodes 0, 2, and 6 because the locations in the first tree do correspond with the locations in the second tree. Meaning that when we traverse through one tree, we want to traverse the exact same way in the second tree. And as you can see, when we traverse to get to the 8 here, we go left, right, and left, but in the second tree, to get to the 8, we go left, left, and right, which is not the right pattern, and therefore we do not remove the 8, as you can see here. We're going to use a private helper method, and we're going to utilize the xChangeX pattern here to modify our tree. So we're not returning a new tree, we're just modifying our first tree here, so it's going to be a void type. It's going to take in another entry that we'll call other, and we're going to use the xChangeX property to change the tree. Remove matching leaves. This will be our private helper method. It'll take in the overall root for the first tree that we're looking at. Then it'll take in the overall root for the second tree that we're looking at. Okay. The private helper method is going to be of the type inTreeNode because we're modifying the tree up here. Remove matching leaves. It's going to take in an inTreeNode, call it node. Then it's going to take in another inTreeNode, inTreeNode. That we'll just keep it as other node. Yeah. As to not get confused with the variable other here. So if both trees happen to be equivalent to null, then we have nothing to do. Or if the first tree is equivalent to null, then we have nothing to do. So we want to look at the case to see when both of them are not equivalent to null so that we can actually do something at that point. So if node is not equal to null, and other node is not equal to null, then what do we want to do? Well, we want to check to see when we hit a leaf in our first tree. And what do we want to do when we hit that leaf? Well, we actually want to make changes if we hit a leaf in the first tree and the data is the same in the corresponding node of second tree. So that's kind of our special case there. So the way we're going to test that is we're going to see if node.left is equal to null. Made a little emoticon thing there. And node.right is equal to null. And then the special case to check if the data values are the same. So if this is all true, then what we want to do here is we want to just get rid of the value of that node. So we're going to set that node value to be equivalent to null. Okay, what happens if we don't reach that leaf node in the first tree? Then we want to keep traversing down the left side of the tree and then traverse down the right side of the tree. And the way we're going to do that is by calling our method removeMatchingLeaves of it's going to take in node.right, and we have to do the same thing to the other node here because we want to check the patterns to make sure that we're matching corresponding nodes. Node.left and other node.left. and then we want to return the node that we're modifying at the very end. And that should be that. This will do the job for us. This will get this all done. This will modify this binary tree. See you guys in the next video.